All right, in this video I'm going to be doing some examples of cross-section volumes for AP Calculus. And I'm going to be working through the 8.2 extra practice set. So, I think kind of like some of the other ones, some of these integrals I will actually go through and compute, and some of them I will set them up and not evaluate them. You know, if it's going to require the use of a calculator, I don't think that it's the best use of your time to watch me type these things into the calculator, so I'm just going to set them up, show you how it's done. Okay, so the first one is y equals 1 plus x cosine x, and y equals 1. R is the base of a solid. Okay, so for me, with these cross-section volumes, I like to just draw the region myself. Okay, this is R. And up here, I've got y equals 1 plus x cosine x, and down here I've got y equals 1. Okay, and it says cross-sections taken perpendicular to the x-axis are semicircles. Okay, so I draw a cross-section perpendicular to the x-axis. Okay, and then I write down the formula for the area of a semicircle. So area is 1/2 pi r squared. So now I'm going to need to get a radius in terms of probably x, so I can integrate dx. So radius is going to be, okay, well, if this is a semicircle situation, the radius is going to be half of that distance. So it's going to be half of top minus bottom. So 1 plus x cosine x minus 1 would just be half of x cosine x. Okay. And then I'm going to just say, well, I know that volume is equal to the integral of area, in this case with respect to x, because I'm cutting along the x-axis. So volume equals the integral of area dx as x runs from 0 to pi over 2. Okay, that's where these things run into each other. I think in at least 2 of the previous videos on the sets that are like this one, I've told you why this is. You know, I've like actually gone through and solved for it. I'm just telling you it's pi over 2 because look, 1 plus pi over 2 times cosine of pi over 2, cosine of pi over 2 is 0. So it's y equals 1 up here, y equals 1 down there. That's why they run into each other at x equals pi over 2. Okay, now I'm going to say integral 0 pi over 2. Area is 1/2 pi times radius squared dx. And radius in this case is x cosine x divided by 2. And then this is definitely the type of thing that's going to require the use of a calculator. So I'm just going to say, okay, this is the setup. You can type that in to your calculator, and that will be good enough, right? You can do that. Okay, move on. Number 2. U is the base of a solid. Cross-sections perpendicular to the x-axis. You can't see that, but they're squares. Okay, so I'm going to draw myself a picture of region U. Okay, and just x-axis r squares. So what I'm going to do is I'm going to kind of label my drawing. Y equals x to the 4 plus 1. This is y equals 2, and that's the x-axis. So I don't think that's going to be super necessary because I'm taking cross-sections are perpendicular to the x-axis. Okay. So I took a cross-section there. The cross-sections themselves are squares, and I know the area formula for a square is you take the base of the square and you square it. Okay, and then I'm just going to say, well, this is base, right? Base equals top minus bottom, so it's top minus bottom. Okay. And 2 minus 1 is 1, so this is equal to 1 minus x to the 4. Okay. We know that volume is equal to the integral of area. Okay, we're cutting along the x-axis, so dx as x runs from 0 to 1. You can see it on the image, 0 to 1. And I've got an area formula, so that would be the integral from 0 to 1 of 1 minus x to the 4 squared dx. Hey, and this is one, I think this one's pretty unlikely that you would have to do this one by yourself without a calculator and multiple choice no calculator, or a free response no calculator even. It would probably be set it up and don't evaluate it. So, you know, if you want to calculate that with a calculator, you'd be my guess, but really the difficulty with these problems is the setup anyway, so that's probably why you watch the video in the first place. Moving on. Number 3. Nope, too far. U is the base, cross-sections perpendicular to the x-axis are rectangles with height 4. Okay. U is the base. Okay, cross sections perpendicular to the x-axis are rectangles with height equal to 4. Okay, well, the area of a rectangle is equal to base times height. Okay, the height is equal to 4, and the base is equal to, again, top minus bottom. It's going to be that same 1 minus x to the 4 that it just was in the previous problem. Just making sure height is 4. All right. So the actual area formula is going to be 4 times 1 minus x to the 4. Okay, volume equaling the integral of area as x runs from 0 to 1. This is going to be, okay, 0 to 1 of 4 times 1 minus x to the 4. And this is one I could definitely see them having you compute by hand with no calculator. So that's going to be the integral from 0 to 1 of 4, got ahead of myself, 4 minus 4x to the 4. And so I'm going to, compute an antiderivative. Let x run from 0 to 1. And then I'm going to get 4 minus 4/5 minus 0 minus 0. And that's going to be the volume of my solid, right? Okay. All right, what's the next one? I need another sheet of paper also. Number 4 is V is the base and cross sections are perpendicular to the y-axis. Okay. We can do that. All right. So number 4, V is the base, cross sections perpendicular to the y-axis. All right. So I'm just going to draw myself a reproduction of V. That'll do, but you can't see it. Okay. So this is V. Cross sections perpendicular to the y-axis. Okay. Draw something perpendicular to the y-axis. Be horizontal. Are going to be isosceles right triangles. Okay, we know that the area of an isosceles right triangle is 1/2 base squared because it's, area of a triangle is 1/2 base times height. And an isosceles right triangle, base is height, so that's where we get the base squared. Okay, and then base, I need to write down a formula for that. Okay, over here I've got x equals 1. Over here, I had y equals x to the 4 plus 1, but I need an x equals situation here. So I'm going to subtract 1 and take the 4th root. Okay, x equals the 4th root of y minus 1. Okay, I know that it's the positive 4th root and not the negative 4th root because I'm living over here in the first quadrant. You can even see right here where x is positive. X is not the negative root of anything because it's positive. Okay, so b being right minus left is 1 minus the 4th root of y minus 1. Okay. I was ready to move on, but okay, evidently it looks like I'm going to be, yeah, this is one that you would have to use a calculator for anyway. So volume being the integral of area is going to be 1/2 base squared. Okay, this is going to be dy as y runs from 1 to 2. All right. And number 5, V is the base. Cross sections perpendicular to the y-axis are quarter circles. This is pretty rare. This might not be an AP calculus, but it's a problem that I'm assigning, so here we are. Let's say that V is the base. Okay. I know that I just said this is x is the 4th root of y minus 1, so I'm just going to call it that. And this is x equals 1. Okay, cross sections perpendicular to the y-axis are quarter circles. Okay, now it might be hard for me to draw, but if this is the quarter circle that I'm building on top, and then this will actually be a radius. Okay, and so I won't need to divide it in half like you do with a semicircle. So the area of a quarter circle is equal to 1/4 of pi r squared. This is my radius because it'd have radius here coming up from there and it being a quarter circle on top. And well, it just means that full distance is the radius. And then I need to write down the formula for my radius. Radius is right minus left. It's 1 minus the 4th root of y minus 1. Okay. So I know my volume is the integral of area dy, and that is y running from 1 to 2, as we saw in the last problem. So this is going to be the integral from 1 to 2 of 1/4 pi r squared dy. Okay. Number 6, we're moving on to this whole scenario here. Y equals the square root of x minus 1, y equals log x equals e, y equals the square root of e minus 1 is going to be the equation of that horizontal line up there, and the coordinate axes. Okay, so now we're going to switch over here and say A is the base, cross-section is perpendicular to the y-axis, a rectangle with height 2y. Okay, that's a type of problem, I mean, who knows by this point when you're watching this, I don't know if we'll have hit this topic yet, these kind of unusual cross-sections, but we're just going to go with it. A is the base. Okay, that's A. Cross-section is perpendicular to the y-axis, so I'm going to need to take this right here. Are rectangles with height 2y. Okay, so area of a rectangle is base times height. Base, well, that's the base right there. It's equal to right minus left. Okay, so on the left I have x equals 0. It's the y-axis. Over here I have y equals the square root of x minus 1. So I'm going to try to get at x in terms of y. So y squared equals x minus 1, and x is going to equal y squared plus 1. So on the right, I have x equals y squared plus 1. On the left, I have x equals 0, so it'd be y squared plus 1 minus 0, and that's just y squared plus 1. Height, they said, is equal to 2y. So it's one of those things where the farther up you go from the x-axis, the taller the solid is, so it kind of makes a ramp. Okay, but that's not really what they're asking. They're not asking what does it look like, what does it mean. They're asking what's the volume of it. What's an integral that represents the volume of it, right? Actually, no, I'm going to do this one by hand. So what's going to happen is volume is going to be, in this case, the integral of base times height, because that's the area formula. So base times height. I might do height times base, same thing. It makes it a little easier to distribute. As y goes from 0 up to the square root of e minus 1. Okay, if you haven't done any of these extra practice problems before and you were looking at me like, why is that line square root of e minus 1? I'll just tell you that, okay, you think here's where x is e. On the curve, on the upper curve, y is equal to the square root of x minus 1. So you take e, subtract 1, take its square root, and that's the y value. And then this horizontal line is all the points with that same y value. All right, so I'm going to say this is 2y to the third, 2y dy, and that would be 1/2 y to the 4 plus y to the 2 as y runs from 0 to the square root of e minus 1. Okay, and then this actually is going to work out pretty well because it'll be 1/2 of y to the 4th. Well, if I take the square root of e minus 1 and take it to the 4th, I end up with e minus 1 squared. Plus, well, the square root of e minus 1 taken to the 2 power is e minus 1. Minus, and then when I plug in 0 here, I get 0, and there I get 0, so that would just be 0. Okay, and that's the volume. 6. And the volume of the solid found by, oh no, it's wrong, number 7, pardon me. We're not doing any rotation in this video. This is just known cross sections. All right, so we're going to take number 7. B is the base. So it becomes like that. Okay. All right, x-axis, equilateral triangles. So I need to copy, okay, this is y equals log x, and this is y equals square root x minus 1. Okay, cross sections taken perpendicular to the x-axis are equilateral triangles. Okay. This is one where it's highly unlikely that you would ever have to do this problem for a college board, situation, like the AP exam or whatever. But I have seen old problems that use that cross-section technique. Who knows, wherever you end up going to school next year or the year after, they might want you to be able to do these problems. I don't know. But I'm just going to tell you, I've said it in class or in a different video or something, but the area of an equilateral triangle is root 3 over 4 times the base squared. If, B is the side length of all 3 sides of the equilateral triangle. It's this. And if you're not sure why that is, I think I'm probably got a video somewhere on my channel talking about, area of an equilateral triangle. You can just search that. And I'll also give you some explanation. Okay, so I've got, this is the base. I would say it's top minus bottom. Base is equal to square root x minus 1 minus log x. Okay. And so my volume is equal to the integral of area as x runs from, what does it run from? 1 to e. And, region B just goes from 1 to e. So that's going to be integral from 1 to e of root 3 over 4 times base squared is square root x minus 1 minus log x squared, because it's root 3 over 4 base squared. Yeah, and this one is just not going to be the type of integrand we're going to be able to take the antiderivative of. Although, I think it is, the one that would stand in your way would be the log of x squared, But, because this u squared is going to be fine. The cross term, I guess you don't know it yet, but you can do it with integration by parts. The negative 2 log x square root x minus 1 is antidifferentiable for sure, but a different day, not today. Okay, so I'm just going to leave it there. Number 8 is C is the base, cross-section is perpendicular to the y-axis. Or, oh, another weird rectangle one. Okay, this is a good set here, it looks like. Okay, this is y equals log x. If I've got cross-sections taken perpendicular to the y-axis, I'm going to need to integrate dy. And so I'm going to need to, what am I going to need to do? Yeah, I'm going to need to solve for x. X equals e to the y. That's x equals e, that's y equals 0. And what am I thinking? Oh, I need to take a cross-section perpendicular to the y-axis and let it be a rectangle with height something. Okay, so the area of a rectangle is equal to base times height. This is the base. Right minus left. So this is x equals e right here minus x equals e to the y. Okay, height is equal to twice the base. Okay, so the area formula is going to be 2 times the base, pretty much. And so if 2b is going to be this. So what I'm going to do is I'm just going to write as, okay, with respect to y, region C, okay, this is x equals e right here, and x equals 1. The height is y equals log of x, and so it's the log of e, which is going to be 1. So y is running from 0 up to the log of e, which is 1. And I'm going to be integrating 2 times base squared. So 2 times e minus e to the y squared dy. And this is one that you could do by hand, but pretty unlikely. So, if you wanted to practice, that would be a good one to do, because you know the derivative of e with respect to y, or e squared with respect to y, well, that would be e squared times y, because e squared is just a number. But the antiderivative of e to the y with respect to y, well, that's e to the y. And you might also need the antiderivative of e to the 2y with respect to y. And all of these things are things we can do, so if we wanted to, definitely do that, but no pressure. Number 9, d is the base, cross sections. Okay, so I'll show you d, e, and f real quick. And this is x equals 0, this is x equals pi over 2, this is y equals 2, okay, y equals 0, that's the origin right there. That wasn't my best graph ever. but we're good. We said D is the base. Okay. And this is cross sections perpendicular to the x-axis are squares. Okay. For a square, area equals base squared. Base is going to be top minus bottom. Right. And, well, that's just going to be cosine x. Okay. Volume is going to be the integral from x equals 0 to x equals pi over 2 of base squared. So okay. That's not an antiderivative that we have to know in this class. If you are interested in anti-differentiating cosine squared x, I'd be happy to show you how to do it. It's just, you know, you just have to hit it with a little trig identity, and then it makes it much easier. You use the, it's like a double angle formula or something. Makes it much easier. So, but this is far enough, and this is something you type in a calculator if you need to know the value. Okay. Number 10. E is the base. E is the one that goes like this. Thank you. Okay. In a different problem set, there was one where it had to integrate with respect to y, and that was annoying because it required two integrals, and I'd say it's good for us to do that once or twice, but not regularly. So, draw a cross-section perpendicular to the x-axis. Area of a semicircle is 1/2 pi r squared. Notice that if this is going to be a semicircle, then radius is going to be half of top minus bottom. Okay, on top I have, that's y equals 2 minus cosine x. And on bottom I have cosine x, so minus cosine x. And that's going to be half of 2 minus 2 cosine x. I might actually keep working on this. And that's 1 minus cosine x. Okay. And I know that volume is going to be the integral of the area formula as x runs from, again, 0 to pi over 2. Okay, and yeah, that's far enough. No cosine squared x by hand. Okay, F is the base, and cross sections perpendicular to the y. Okay, this should be interesting. Okay, so, oh goodness. Not a good sketch of F, but it's all right. Cross sections are perpendicular to the y-axis. Okay. They are semicircles, so again, area is 1/2 pi r squared. Radius is going to be half of right minus left. Okay, well, if this is y equals cosine x, and I need to solve for x, all I can do is take inverse cosine. So x equals arc cosine y. And then this is the line x equals 0 because it's the x-axis. Yeah. And then y is running from 0 up to the maximum value of y equals cosine x. Well, that would be 1. Okay. So radius is going to be half of this distance, so it's half of right minus left. Okay, yeah, half of right minus left. And then I know that volume is equal to the integral of the area formula. So that would be, as y runs from 0 to 1, 1/2 pi, radius is going to be half of arc cosine y squared dy. Oh, whoops. And there we go. That's fully set up. Yeah. I don't think that's one you would ever have to do by hand, so let's move on. Oh, no, that's it. That's the last problem. That's all I got for you for this video. Thanks for watching.